Hello students. Here today we will talk about two quantities which actually talk about the change in position with time. So now you will actually see when the position changes with time, how do we interpret the motion of the object? So we will now focus on these two quantities, that is distance and displacement, because these are the two quantities which will talk about the change in position with time. Since motion is nothing but the change of position with time, right? So these two quantities will play an important role in describing the change of position, in describing the motion. And these two quantities are distance and displacement. Now let's see what is distance. Distance is the total length of path an object travels from initial to final position. That is the entire path which a body is covering. That is why it's also called path length. The entire path through which you are reaching your destination from your initial position. That is known as distance, or you can say path length. So now, what is displacement? Displacement is the shortest distance between initial and final position. Note this point, it is the shortest distance. Okay, that means when we talk about displacement, we are not bothered about the path which was followed to reach the final position from initial position. It is only the shortest distance from initial position to final position. So let's take the example to understand the difference between distance and displacement. Let's suppose we have a small boy on the cycle. Okay, so what do you see? What is the position of boy right now? He's obviously at his home. Okay, so this is his house, so he's at rest. Correct. Now he starts moving. Okay, say he starts cycling and goes from his home. Say suppose he goes to masjid. Okay, he goes from his home to masjid, to mosque. Okay, then he comes to this McDonald's. So now, what was the change in position of the boy? Okay, as you know, the boy was changing its position first from home. Okay, say point A. Okay, he reaches till mosque, walks, he reaches till mosque, say point B, and then from mosque he reaches to McDonald's, say point C. Okay, now in this case, what is the total distance covered by this boy? When I say distance, I mean entire length of this path which he covered. So what was the path followed by the boy? First he followed this path from home to mosque. It means A to B, AB. Then he followed this path from mosque to McDonald's. That is BC. Okay? So that means when I talk of distance, as I mentioned before, it is the total length of the path, total length of the path. That means total length of path covered by boy from home to McDonald's. Okay, because he reaches from home to McDonald's. Now it means here I am not bothered about the path which was followed by the boy. So here, what is its distance? What is the distance of a boy? It's AB plus BC, right? Distance with AB plus BC, because he covers path AB and then BC. Okay. Now, what will be the displacement in this case? Since we know displacement is the shortest path, shortest distance between the 2 points, between the initial and the final path. So it means we are not bothered about the path which was followed by the boy. If I am bothered about anything, that is initial position and final position. So what is the initial position and final position of the boy? See, its initial position is here, A, at his home. This is the initial position. And finally he reaches to McDonald's at C. It means it's its final position. Okay, now what is the shortest distance? Obviously this A to C, initial to final, this is the shortest distance between initial and final position. It means AC is the shortest distance. Okay, so when AC is the shortest distance, it means our displacement is AC. So if you say in a way, both the quantities, distance and displacement, are actually talking about how the position of object is changing with time, right? But there is a difference between the two, and I hope I am able to explain you the difference between distance and displacement. Now let's look at the other example where you can see when you have distance is equal to displacement. Okay, because there will be certain scenarios where your distance and displacement are the same. So let's look at one such example. Okay, let's suppose again a boy starts from his home and he goes directly to, say, McDonald's. Okay, he directly goes from his home to McDonald's. Now in this case, say this is at home, this is its point A, and at McDonald's this is its point B. So in this case our distance would be A to B, AB. Now what is the displacement in this case? As we know, we require only initial and final position. So this is the initial position A at home and this is the final position B, McDonald's. Okay, so what is the shortest distance between these initial and final positions? It's again A to B, A, B. So in this case our displacement would be A, B. Okay, so here we have both distances and displacements equal. Okay, why it is equal? Because the boy followed the shortest route between initial and final position. Okay, so what we conclude from this, the first thing is when we talk of distance, the path which is actually followed by the object matters. Okay, but where you talk of displacement, the path actually follows doesn't matter. It's only determined by initial and final positions. Okay, now let's look at another example where you will see where distance is not equal to this 0 but displacement can be equal to 0. So distance is not equal to 0, right? That means the object is covering some distance, but displacement comes out to be 0. Interesting now. Let's look at the scenario. Let's again consider the same boy and he starts from his home and goes to McDonald's. And what happens when he reached McDonald's? Say, for instance, he forgot his uh, purse and he comes back to his home. Okay, it means he comes back from McDonald's to his home. So, in this case, what is what distance? First, he's at home, right? Say at point A. Then he reaches here, McDonald's, say B, and then comes back again home. It means it comes back again to A. Now the total distance would be first A to B, then B to A. It means AB plus AB, and that will be 2 times AB because it's covering the same part twice. So this is our distance, and it's not equal to 0. But now what will be the displacement? Here, what is the initial point? A, this is the initial position home, and what is the final point? As he comes back from B, it means it's not as final its final point. It because it turns back, it comes back and reaches here, and this is its final position. It means its initial and final positions are the same. So what is displacement here? When initial and final position same, there is no path, there's no length between, no distance, shortest distance between initial and final position. It means both the positions are same. That means our displacement will be 0, right? So now I hope you are able to understand what is distance and what is displacement.